Sequences and Series, Lesson 6. You start right here. So just not even look at this. So we start with the definition. The definition is for an infinite geometric series. An infinite geometric series has an infinite number of terms. For an infinite geometric series, if the sequence of partial sums, which we did yesterday, converges to a constant value, like any number, as the number of terms increases, then the geometric series is called convergent. And if it doesn't, it's called divergent. This sum, though, if it's convergent, this sum is called the sum to infinity. And we denote it this way, S, and then a little subscript infinity below. Let's just start by calculating a few of these. Determine whether this infinite geometric series has a finite sum. In order to do this, we're going to calculate some partial sums. What do we mean by a partial sum? Well, the sum of just some of the terms, like S4. Let's calculate S5. And then let's go way out there and calculate S10. Remember from yesterday, your formula for S sub n is equal to T1 bracket 1 minus r to the n all over bracket 1 minus r. Okay, that's the formula for any partial sum. So we're going to need to know term 1. Let's set up a little key here. Term 1 in this case is 1/2. I need to know r. R is a quarter divided by a half. 1/4 divided by a half. And what do I do with a fraction over a fraction? Well, I'm going to take that, I'm going to flip and multiply, and I hope you can see that your r value is in fact 1/2. Just check. If I take a half and multiply by a half, I get a quarter. Times a half, I get an eighth. Times a half, I get a 16th. Okay, so there's my r value. The sum of the first four terms is term 1 bracket 1 minus r. I'm going to write it as 0.5. I think it'll be easier to put in my calculator, to the power of n all over bracket 1 minus r, 1 minus 0.5. Okay, so could you plug that in your calculator and give me 4 decimal places? Okay, check your work. Well, let's do the same thing for S5. It's equal to term 1, I'm going to use 0.5 for a half, times 1 minus r to the power of n, in this case 5, all over bracket 1 minus r. Okay, plug that in your calculator and tell me what you get. And give me 5 decimal places this time. I'm getting 0.96875. Of course, I could have taken the sum of the first 4 terms and added 1 over 32, one more term, the 5th term. Okay, now could you do it for S10? S10, I've got term 1, 1 minus r to the 10th, all over 1 minus r. And I think we all know now that 1 minus a half is a half. And plug that in. I'm getting 0.999023. So if you look at these partial sums, 0.9375, 0.96875, 0.999023, can you see that these numbers are getting closer and closer to 1? So an estimate for the finite sum is 1. So we're saying that the sum to infinity, if you let the n get bigger and bigger and bigger, you're going to end up just getting the answer 1. Okay, let's do it for another example. So 0.5, 1, 2, 4. So here is term 1. Tell me what r is. Well, to find r, take any term, divide it by the previous term. I get an r value of 2. So I think we're going to find in this one that your series will not converge. So if I look at the sum of the first 2 terms, oh, how about I forget about fancy formulas and I just add them together. The sum of the first 3 terms, 0.5 times plus 1 plus 2. The sum of the first 4 terms, 3.5, got me to here, plus 4, I'm getting 7.5. How about the sum of the first 10 terms? Now I do need a formula. It's going to be term 1, bracket 1 minus r to the power of n all over 1 minus r. Okay, plug that in your calculator, and I think you should be getting 511.5. So you can see that these sums just keep getting bigger and bigger. So as the number of terms increases, the partial sums also increase, which tells us the series does not have a finite sum. What's the difference between these two? They both start at the same spot. The difference is in the r value. This r value is a proper fraction, and this one is bigger than 1. When the absolute value of r is less than 1, then your series will converge. If the absolute value of r is bigger than 1, it will not converge, it will diverge.